So now that we have a sorted data structure, we can get into some searches. And I'll just briefly mention the sequential search. And frankly, for an array as small as this, the sequential search would be fine. It's only when you get to large numbers that the binary search is way, way more efficient. So, but if this were a sequential search, it's just you look through. If we're looking for Mary, is this Mary? No. 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 Is this Mary? Yes, we found Mary, and we send Mary back. That's a sequential search. Just loop through the array until you find what you're looking for. But this will be a demonstration of the little bit more involved and much more beneficial and wonderful binary search. So for the binary search, we are going to make progressive dividing in two of the remaining array until we zero in on what we're looking for. So we're going to need to keep track of a low and a high and calculate a mid. So these will work fine. What we're going to do is have a low and a high. I'm going to do it this way so I can actually read it well. So low and high. And we're going to calculate a mid. So mid. The way we calculate the mid is we go low plus high divided by 2. So in the beginning, it's going to be 0 plus 0 plus 7. 0 plus 7 is 7 divided by 2. Integer division is 3. So 0, 1, 2, 3. This will be our mid. And then we look at the mid. And we say, is the mid what we're looking for? Well, good question. What are we looking for? Let's put that over here on a full sticky. Let's call it key. And let's look for George. Right. So we had the low, had the high, calculated the mid. Ask the question, is where we're at, what we're looking at, equal to what we're trying to find, the key value we're trying to find? Is Chisanga equal to George? No. Then what you're going to usually see in terms of the way this is written, because it could be greater than, less than, whatever, is else, if this is not what we're looking for, if what we're looking for is less than what we're looking at presently, then we'll look down over here. That's not the case, though. The way that I'm doing it, I'm looking for George, and George is not less than Chisanga. So we go to the third part of that, if, else if, else if. So the final part is else, we're going to look that way. So if we're going to look that way at this remaining part, we can disregard all of this, and that's the wonder of the binary search. Each step you reduce the remaining amount that you have to look through by a half. So we're going to get rid of all these cards, and we can even get rid of Chisanga because we've already looked at the mid and we know that it's not Chisanga. So we do not have to deal with those cards in this demonstration anymore. But we do need to deal with these. So we're going to use the same approach. We're going to have a low and a high, calculate a mid, ask if that's what we're looking for. So the low is going to shift. This variable low is no longer going to be down here. It's going to be here. What's this? This is the mid plus 1. So now we repeat. Like I say, we repeat the same thing. These are now dealt with over here. No pun intended there. So, right, low plus high divided by, oh, and by the way, the other thing to mention that I didn't mention so far is you only repeat this loop as long as high is greater than or equal to low. And we'll get to what can happen in terms of the crossing over in a moment, but we asked, going to repeat with the while high is greater than or equal to low. Is high greater than or equal to low? Yes. So, low plus high divided by 2. 4 plus 7 is 11. Integer division by 2 is 5. So the new mid is 5. This was 4, so that's right here. The mid is here. And we ask the question, if where we're at, what we're looking at, is equal to what we're looking for, then we found it. But that's not the case. Then the next question, which we used over here, we're going to use again, if what we're looking for is less than where we're at, and in this case it is, it's not the low that's going to shift, it's the high, because we know it's over here now. If what we're looking for is less than where we're at, it's over here, it's not over there, so we can disregard all that. The high is in the wrong place. We can move the high down to the mid, and not even just the mid, but the mid minus 1. Because we've already looked at that mid. And so now the low and the high are actually pointing to the same element, but let's repeat one more time. Go up to the top of the while loop. The while says while high is greater than or equal to the low. It is greater than or equal to the low. High plus low divided by 2. This was 1, 2, 3, 4. It was 5. 5 plus 5, 10 divided by 2 integer division gives us 5, of course. And so the mid will also be here. And we ask the question, if where we're at is what we're looking for, and in this case, it is. What do we return? What do we do? We return. We usually will return the index of what we found, because more often than not, as you get more sophisticated programming, you won't just be looking at primitive types or strings, you'll be looking at objects. And so George will have some other information attached with him, like his grades and his classes and whatever else. So we will usually return the index where he resides in the array. Yeah, and I better finish this off just by saying, what if we weren't looking for George? What if we were looking for Georgette, for example? If we're looking for Georgette, then it does not equal where we're at. So what's going to happen is we're going to go to, what would it be? It would be the high is going to switch. So the high is going to go down here. This is the way it's going to work. And we're going to get back up to our question, while high is greater than or equal to low. Well, it's not. So if we did not find, if we were looking for Georgette and Georgette was not in the array, then usually what you do, particularly when you're sending back element numbers, is you would send back a -1, because there is no -1 as an element number in the array. But we found George, and George was at 5, that's what we send back, and that is the binary search.